The RANGE MIPS is the most complex and technologically advanced helmet in Giro's product line. From the truly integrated conform-fit technology, to the durable yet semi-flexible construction, to the multi-directional impact protection system, the RANGE MIPS represents a step forward in helmet design. In order to understand how we can make a helmet this complex, let's take a look at the process required to create it. The first step is industrial design. We start with quick hand sketches to establish a design direction, and then we move to half-scale models sculpted in foam. Next, full-scale designs are sculpted in clay, and then scanned into CAD so we can reproduce them on 3D printers. This full-scale model confirms the fit and is also used to validate seamless compatibility with Giro goggles. When you see the RANGE MIPS, you see a single object. But it takes nearly 100 parts to make this helmet, and every one of those parts has to integrate seamlessly. The low-friction liner, which is an essential component of the MIPS system, is just one example of how each part needs to be carefully designed, engineered, tested, and manufactured for optimal performance. The tooling required to make the RANGE MIPS is highly complex and can take up to 60 days to complete. We make sure that every piece of tooling, from the outer shell to the EPP liner and MIPS liner, is precisely machined for an optimal fit and finish. A helmet as advanced as the RANGE MIPS deserves a beautiful finish. The graphic process starts with a flat design, either hand-sketched or rendered on the computer. Colors for painting are hand-picked for the shell, all components, and the trim. Graphic designs are created in detail, and specification packages are handed off for sampling and final manufacturing. The heart of the RANGE MIPS helmet is the EPP foam liner, made of expanded polypropylene. To create this EPP liner, polypropylene pellets are expanded in a chamber using pressure and gases that transform the tiny pellets into loose foam beads. Once expanded, these beads are injected into a mold to form the EPP liner that will become the core of the helmet. Truly unique to the helmet world, the RANGE MIPS uses conform-fit technology. The two-piece shell literally forms to the individual contours of your head by expanding and contracting with the turn of a dial. Conform-fit technology requires a complex tooling made of multiple pieces, injected with a proprietary blend of polycarbonate plastic into the mold. Heat, pressure, and steam, followed by water cooling inside the mold, form the shell of the RANGE MIPS helmet. The shell is then polished to a high gloss to ensure a smooth finish and primed for painting and graphic application. Then the shell is clear-coated for a protective finish and the final graphics are applied. Next up is assembly of the shell components and fabric-wrapped EPP liner. At this step, we also install the conform-fit system, adjustable ventilation system, straps, Fidlock magnetic buckle closure, ear pads, and exterior goggle retainer. The final step is the MIPS low-friction liner assembly and X-static padded liner application. Once assembly is complete, the helmet is inspected for quality and then packaged for shipment. Every helmet we sell meets or exceeds industry testing standards for impact management, retention, and other factors that can help to reduce potential brain injuries. We benefit from world-class testing resources. Our in-house test lab, the Dome, houses more than 50 test fixtures that range from standardized tests to fixtures that we've designed to evaluate rotational energy management. Once we've completed testing and certification, the helmet is ready for sale. The entire process from industrial design through final certification takes almost 3 years to complete, with thousands of hours invested by the whole team here at Giro. But it's worth it to us, and we're proud to have created a helmet as advanced as the RANGE MIPS, a product that can make a difference in people's lives.